Hi, welcome to the Olympiad geometry. Let's continue our study on intersection circles. Before we start, if you think this video would be helpful, please click the like button, comment, share, or subscribe to the channel. Thank you. Let's see the problem. In triangle ABC, AB equals to AC. D is a point on AB extension. E is on AC. And CE equals to BD. DE meets BC on F. Circumcircle of triangle BDF intersects circumcircle of triangle ABC on G. Prove GF is perpendicular with DE. So for this problem, we already see two intersection circles, right? And we only know that AB equals to AC, BD equals to CE. AB equals to AC give us a relationship between angle ABC and angle ACB, right? But for here, the problem, we already see the two intersection circles, so we actually want to find out as much as possible that we can of the angle relations, right? Because we want to prove that the GF is perpendicular with DE. And that's a angle relationship, right? So the first thing we need to think about is that how to use this BD equals to CE. BD is here, CE is here. So if we connect to BG, this actually like fix a step when we have two intersection circles, right? Always connect the intersection point. It gives us a lot of information. So just connect the BG, and also here we need to connect to GC. Yeah, that's enough for now. So we know that angle DBG equals to angle DFG, right? DBG equals to DFG. They all reference to the chord DG. And angle DBG, because ABGC is a cyclic quadrilateral, so angle DBG equals to angle ACG, right? So equals to angle ACG. That becomes angle DFG equals to angle ACG, which is angle ECG. Okay, DFG equals to angle ECG. So from here we know that EFGC are cyclic. Right. Now look at here. BD equals to EC. And we know that EFGC are cyclic, BFGD are cyclic. So we connect DG here. And we connect EG here. This side equals to this side. And this angle, the angle DBG, equals angle ECG, right? Looks like we may be able to prove these two triangles are identical, right? So let's see this angle, the angle DGF, DGB, right? Angle DGB. equals to angle DFB equals to angle EFC equals to angle EGC, right? So this equals to this because this BDGF are cyclic, and the angle DFB equals to angle EFC, and because FGCE are cyclic, so these two angles are equal. So we got this one. Then we know that at least, right? So actually we already can prove the triangle BDG and the triangle actually CEG are identical, which means that we got BDG triangle CEG, and also we got DG equals to GE, right? DG equals to GE. And now we know that if GF is perpendicular with DE, then because DG equals to GE, F must be the midpoint of DE, right? So basically, now the problem is that can we find a way to prove that DF equals to FE? There are several ways. Let's think about it in the maybe the easiest way. So we want to prove DF and FE, right? Let's do extend CB here, and from D we do a parallel line to AC, right? So we know that, let's call this point as P. So we know that DP is in parallel with AC. So this angle, the angle DPC equals to angle BCA equals to angle CBA equals to angle PBD, right? Because these two lines are in parallel, so this angle equals to this one, and because AB equals to AC, so this one equals to this one equals to this one, so eventually this one equals to this one, which means DP equals to DB equals to EC, right? So this segment equals to this segment, and the angle equals to this angle equals to this angle. So we know that triangle PDF and the triangle CEF identical, so which means DF equals to EF, right? And based on this, DF equals to EF, DG equals to GE, so GF is perpendicular with DE, right? GF is perpendicular with DE. And for this problem, let's dig more, not just stop at the conclusion. We know that DG equals to GE, which means if I mark this angle as angle 1, this would be angle 1, right? The angle FEG would be angle 1. Therefore, the angle FCG would be angle 1, right? Equals to angle 1. And here, the angle GBF equals to angle 1, right? Which means BG also equals to GC. right? Which means G is the midpoint of arc BC. And because AB equals to AC, so AG is the angle bisector of angle BAC, and AG is perpendicular with BC, right? Okay, that's it. That's basically what we can what we can get. We can derive from this problem. So for this problem, the difficulty would be on how to transfer the edge problem set to angles, right? And once you get a lot of angles to be equal, you're on the right way to find the to approach the final conclusion. Okay, I hope you like this video. See you in next one. Thank you.